So the first problem over here, it says a tennis ball is thrown straight up with an initial speed or initial velocity of 22.5 meters per second. It is caught at the same distance above the ground. How high does the ball rise? How long does the ball remain in the air? And just a little hint, the time it takes the ball to rise is equal to the time it takes to fall. Okay, and we already know that, so I guess I could just remove that hint. Okay, so what is the given information that we have here? So first of all, let's think about what's happening here. A tennis ball is being thrown straight up in the air with this amount of speed, and it's caught at the same distance. Okay, so right off the bat, what is the initial height of the ball? 0, right? And what is the final height of the ball? 0 meters, right? Initial velocity is 22.5 meters per second. How high does the ball rise? Okay, wait a minute. So we're trying to find out how high it rises. This is starting to get a little confusing here. This is the initial position and this is the final position. You know what? Let's take a little break here. I just want to show you a little something. I'm just going to erase this information. Okay, well, say if I wasn't given the initial velocity. Okay, so if I wasn't given an initial velocity in this problem, hey, you know what? So we know that the initial velocity is equal to the final velocity, right? But if I wasn't given the initial velocity, then I also wouldn't be given the final velocity, and those would be two unknowns right off the bat. And that's going to make our problem very complicated. I don't like that. That's going to be a nuisance for us, right? But we do know that this trajectory is very symmetric, right? Here's what I'm going to do. I'm going to drop a dotted line down here like this. And let's say this. Let's say that the initial position is over here. So this is our initial height right here. And let's say that the final height is up here. Hey, you know what? Okay, so if we're to do that, what is the benefit of saying that this is the initial position, the initial height, and this is the final height? Well, what's nice here is that we know that the velocity here at this point at the highest level is what? 0 meters per second. So right off the bat, if we set it up like this, say if we just ignore all of this and we just say, hey, you know what? This is going to be the initial position and this is going to be the final position. What do we know right away? Hey, you know what? This is going to be the final velocity at this point, which is at the highest point of its trajectory. So that's nice. I like that a lot. That idea that we know a piece of given information right off the bat. So let's do that. Once again, we're just going to ignore for now. And we do know that the object is going to fall back to the ground and hit the ground. So we'll keep that in mind. So we do know that the initial speed, the initial velocity is 22.5 meters per second. If we're defining that this is the top of the trajectory, then the final velocity will be 0 meters per second. We're defining that. Another piece of information that we have is, what is our acceleration? Well, it's acceleration due to gravity, right? We have the force of gravity acting on this object throughout the entire trajectory. So what's the acceleration? And what else do we have? Oh, what's the initial height of this object? Look at all this information that we're pulling out. How high does the ball rise? Okay, so it looks like that this is what we're trying to find here. How long does the ball remain in the air? Okay, so the reason why we actually just did that last that task where we had the T rise and the T fall, T total and T fall was simply because of this right now. Okay, so we are defining that this is the initial position. We're defining that this is the final position. If that's the case, if we solve for time, understand the idea that you're solving for the time from here to here. Let's say that this is equal to, let's call it 3 seconds. If this is 3 seconds from here to here, what is the total time? It's asking us, how long does the ball remain in the air? From here to here, it's 3 seconds. The ball is in the air for a total of 6 seconds, the total time. So that's the reason why we're doing this. All right, so we're trying to find out this, but when we calculate this, what we'll find is that because we're saying that the initial position is here and the final position is here. If that doesn't make sense, rewind this video and play it again. Okay, so let's do this. Let's do our calculations right now. Being that we talked a lot about the time and everything, let's calculate that first. So if we're trying to find out what the time is, what's the variable that we simply don't care about? Our final height. Okay, so coming over here, what is the kinematic equation that we're going to be using? We don't care about the final height, right? So do we have final height over here, YF? No. Do we have YF over here? Yep, right there, right there. Do we have YF in this equation? Oh yeah, yep, right there. And do we have YF in this equation? Okay, so that's right there. And so process of elimination, once again, helps us out finding out which equation to use to find our delta T. So that equation, once again, was VF. Okay, so now all we have to do is plug in our given information, solve from there. So VF is equal to 0. Once again, this being the final position, the height of the ball, maximum height 0. And initially we are traveling at, well, the object is traveling at this speed, negative 9.8, and the delta T is what we're interested in. Okay, okay, so we have here 22.5 plus a negative 9.8 times delta T. We have two terms here. Terms are once again separated by positive signs and negative signs. What we want to do here is isolate the delta T. So this term over here, we're going to leave this alone for now. Let's get rid of our positive 22.5. How do you go about doing that? Let's subtract 22.5 by both sides of the equation. And we're left with our negative 9.8 times delta T. Okay, so once again, we're going to be isolating our delta T. So we have a multiplication of negative 9.8. How do you get rid of a multiplication of negative 9.8? Divide by negative 9.8 on both sides of the equation. I'm going to do this in the calculator right now and see what we get. Keep in mind that once again, we have negative 22.5 divided by a negative 9.8. So what are we expecting? A positive answer or a negative answer? Keep that in mind. And we get our answer of 2.3 seconds is equal to our delta T. But once again, we did that for, this is our initial position, that's our final position. The way that we know that this is definitely our final position is because we're saying that the final velocity here at this point is equal to 0. We toss the ball straight up, it's going to go up, 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 up. Pause. And we're defining that to be our final position, and we know that because our final velocity is 0. So the time that we actually got is 2.3 seconds. That's this time right here. What we're really interested in is the total time. So what is the value of the total time if the time to rise is 2.3 seconds? Do this in your head. 4.6 seconds, right? All right, and that's the first problem. Okay, so now that we got that, we're going to solve out for our YF. What is it's asking us, how high does the ball rise? That's the YF. This is the initial position, that's the final position. The final position will tell us how high the ball rises. So let's find out our YF. What do? We say to ourselves, I don't care what delta T is equal to. I'm just going to come right back over here. Let's clean this up a little bit. Give me a quick second over here. Please be patient. There we go. All right, so we are going to be saying that we don't care about our delta t because we're searching for our YF. Okay, so let's look for our delta t's. Coming through here, we got delta t right there. I'm just going to stay consistent. Let's go with our red. Okay, coming through here, we got delta t right there. Not going to use that one. We have delta t twice in this formula, so we're obviously not going to be using that one, and we will be using this one over here because it doesn't have the delta t. Let's write out that formula. Make sure that you write this out correct. Okay, and that looks good. All right. So here we go. Let's start plugging this in and solving out for, once again, our YF. So VF squared is 0 squared, 2.5 squared. Okay, so we know right off the bat the subtraction of 0 is not going to actually do anything for us. Neither is, so we have 0 squared over here. We can't really cross this out, being that it's the only thing that's on the left-hand side of the equation. We can't cross that out. We're just going to drop down our 0. It's a nice little placeholder for us. All right, so let's simplify this. What's 22.5 squared? 22.5 times 22.5. We got 506.25 plus, okay, well, we have positive 2 times a negative 9.8. Will that result in a positive or a negative number? That's going to result in a negative number. That's going to result in negative 19.6. And that's being multiplied by YF. Once again, we have two terms over here. Terms, once again, are being separated by plus signs and minus signs. We have a 506.25 minus 19.6 times our YF. We're trying to isolate our YF, so let's get rid of our positive 506.25 by subtracting 506.25 on both sides of the equation. Okay, so we have a multiplication of negative 19.6. So we have to divide by negative 19.6 on both sides of the equation. We'll have a negative divided by negative, so therefore we'll get a positive answer. And that will be, so we have that, divide that by 6, or negative 19.6, and we have 25 point, let's call it 8 meters. You know what? This should be a 8 right here, if you're rounding correctly. Okay, so there you go. Once again, the key thing to remember here is this. Just making sure that you understand the concept of this is our initial position, this is our final position, and that's the way I'm going to be treating all these problems. We're just going to have to consider, when we solve out for our delta t, are we solving out for the t rise or t total? If we want our answer to be the t total and we calculate out the t rise, then what we have to do is just multiply that by 2 to get our total.